2-8 for Algebra 2, two variable inequalities. So let me get down. I'm going to need some graph paper for this. I'm going to scroll down for a moment here. And this is the first one I'm going to do. I'm going to write down a couple of rules for this too. Graph, these are the directions, fancy ones. Graph y is greater than or equal to 3x minus 1. Okay. Now what we're going to do is we're going to start by graphing a boundary line. It's called a boundary line. You're going to, and it's really the same thing except it's got an equal sign. All right. Now before I go any further, there's a couple other things here too. If it's greater than or equal to or less than or equal to, it will be a solid line. If it doesn't have that line underneath it, if it's just greater than or just less than, then it's a dashed line or dotted line. And that's an important thing for you to remember. Okay. Yep, we'll just start right there. Okay. So I'm going to graph the line y equals 3x minus 1. Quick reminder, this is like y equals mx plus b, which means the slope is 3 or 3 over 1. You can always put a fraction or make something into a fraction. You can put it over 1. The y-intercept is negative 1. Okay. That's the y-intercept. And 3 is the slope. Okay. So that's where I got those numbers. And so let me graph that. Y equals 3x minus 1. So I'm going to go over my graph here. This is negative 1. This is 2. Just mark off a couple of numbers here. It's negative 2. Here's my x-axis. Here's my y-axis. So I'm going to start at the y-intercept, which is negative 1. Put a dot here. And then I'm going to do the slope, the rise over run. Remember, positive slope goes up and to the right. So I'm going to go up 3, right 1. 1, 2, 3, right 1, which lands here. Up 3, right 1 from there. 2, 3, right 1. Remember, you can always check your slope with that little triangle. You know, is your slope actually 3 over 1? Yes, it is. Okay. All right. So I got a couple points here. I'm going to make my line. Let me zoom out a little. Make it nice and long. And there's my line. Okay. Now, I'm not done because this is an inequality, which means you're going to shade one side of the line, okay? If I take that same equation, the y is greater than or equal to 3x minus 1, we're going to first do a test point, okay? I'm going to show you that way. There's two ways I'm going to show you. All right, so I love using 0, 0, and I'll show you why. This one's pretty close to 0, 0, so it's a little risky, but I'm going to play full confidence that my graph is accurate. You don't want to pick a test point that's on the line, okay? The reason for that is because the only thing that actually tests is whether it's or equal to, okay? So pick one that's not on the line. So if I pick 0, 0, remember this is the x and this is the y, so if I plug those numbers in, 0 for x and 0 for y, and we're going to see whether this is true or not, okay? So I got 3 times 0 minus 1. Is that in fact less than or equal to 0? Let me simplify this. 3 times 0 is 0. 0 minus 1 is minus 1 or negative 1. So I got 0 is greater than or equal to negative 1. Just a quick reminder that, you know, all negative numbers are in fact less than 0 or less than all positive numbers. So this is true, which means this side of the boundary line where that test point is, that's my solution side. So I'm going to shade everything on that side, all right? So you shade everything. If that had been false, I would shade everything on the other side of that line from the green point, which would have been, you know, everything over here. But in this case, it was true, so that's the side that I shade. Okay. And if you got questions on that, bring it to class. So that's how you do the first problem. Number 2. Graph y is greater than or equal, not or equal to, just greater than, negative 2x plus 1. All right, so once again, I'm going to graph the boundary line, which will be, if I take, the y-intercept is 1, slope is negative 2. Start at the y-intercept. This is the y-axis, this is the x-axis. Here's negative 1, slope of negative 2 or negative 2 over 1. So it's easier to have it in a fraction form when you're graphing. So negative slope goes that direction, so I'm going to go up and to the left or down and to the right. Up 2, left 1, up 2, left 1, up 2, left 1. Am I out of space yet? No, one more. Okay. Now, this is going to be a dashed line, not a solid line, which means it's going to make it worse here for my software because I can't do a dashed line with this software, so I'm going to have to freehand it. So that's what that looks like. Forgive my non-perfect straight line. And now I'm going to have to figure out which side to shade, okay? Now I'm going to show you a trick actually that I learned when I was young and in high school. I had a high school math teacher named Mrs. Brock, and I graphed about 50 of these, as I remember, and finally I went into her and I said, Mrs. Brock, every time I've got something like this where it's y is greater than or y is greater than or equal to, and everything, there's nothing else on that same side of the inequality with a y, I'm shading above the line. And every time I've got something like this where it's y is less than or y is less than or equal to, I'm shading below the line. Does that work every time? And she said, yeah, it does. And I said, oh, okay. So how come we're doing all those test points then? Was my next question, as I remember. And I'm not sure she had such a good answer for that. I think some of it might have been, that not every linear equation has y all alone on one side of the equal sign. But anyway, the test point can be nice, especially when we get to systems of inequalities too. But I kind of like this one. So that's something you might want to write down and take to heart. Now, when I say where it crossed below the line, what you're actually looking at is where it crosses the y-axis, because that's where the y values lie. So when I say y is less than, like this one, that one's actually y is greater than, so I should look at the other one. Since it's that, I'm looking at where the line crosses the y-axis, which means the y values that are greater than are that direction. So that's the side of the line you're going to shade. And there it is. Okay, and that's what you get. All right, now you could also have done the test point. If you had done a test point, suppose you had plugged it in, you would have also found out that you could shade that side of the line. Okay, so that was number 2. All right, so number 3. This one, 3x plus 2y is greater than or equal to 6. All right, so this one is not in y equals mx plus b form. All right, so you're kind of faced with two choices. You could graph this with x and y intercepts, plug in 0 for x, and then figure out what that is, and 0 for y. That would be one way. Pretty sure we've gone through that, and, if you remember how to do it. I prefer just to manipulate the equation. Really, don't be afraid of a little bit of algebra here. I got this 3x, I want to get it over there to the other side, so the opposite of adding 3x is subtracting 3x, which leaves me with 2y is greater than or equal to 6 minus 3x, okay? And last but not least, I'm going to divide by 2, divide everything by 2. Remember, if that was a negative number and I was dividing it, since it's an inequality, I would flip that arrow the other direction, okay? In this case, it's positive, so I don't have to flip it, but I just want you to remember that, because occasionally it'll come up. All right, so I got y is greater than or equal to 6 divided by 2 is 3. 3 divided by 2 is 3 over 2. Okay, now if you want to be a stickler, you know, and say you have to have the slope and the x first, you can rearrange it into this. Just remember that negative sign sticks to the 3/2, not to the 3. So it's not -3, it's +3 and -3/2, that's all. All right, so now I've got my slope, I got my y-intercept. I'm going to go over to my graph. Y-intercept is 3, which is here. Negative slope goes that way, so I can go up 3, left 2, 1, 2, 3, left 2, and that gives me negative slope. I can also go down 3, right 2, which will land me there on the x-axis, and then I can graph my line. All right, so let's see, this is or equal to, which means since it's going to be a solid line, since it's one of these two. Okay, and let me take that point there, just drag it. There we go. Throw a couple arrowheads on there. That line does go forever and ever in 2 directions. Okay, now let's talk about which side of the line am I shading. So I'm going to go back down to this version of the equation down here, or that one, which are really they're all the same in fact. Y is greater than or equal to. So since it's y is greater than or equal to, I'm going to shade above the line. Let me pick out another color here. I'm feeling purple today. All right, here we go. There we go. Shade that side of the line. So, which means, you know, that any point on that side of the line, here, those are all solutions to that inequality. There is an infinite number of points in that area, which means there's an infinite number of solutions, which makes sense. It's an inequality. If I said, tell me all the numbers that are greater than 5, it would take you a long time because there's an infinite number of them. All right, so that was number 3. Number 4. All right, that one. Y is greater than the absolute value of x minus 3. Okay, so now you're going to have to think back to the last video. If I was just to, let's take it one thing at a time. Let's graph the absolute value part. Suppose I was just going to go graph this. All right, this is a V, and it's got a horizontal translation of 3 units to the left, which means if I go over to 1, 2, 3 units over, I knew it was to the, oh, I'm wrong, it's to the right. You'd think it was to the left because I was looking right here at this -3. But remember, when it's inside the absolute value sign, it's actually the opposite side of what you'd think. So my spot over there is wrong. It's actually going to be over here, all right? Okay, so it's over there. And it's a V, and this has A would be 1 because there's an implied 1 in front of that right here, which means it's going to be slope of 1. So if I take this graph over here and I make it a V with a slope of 1 like that, one more thing. Since it's one of those two, it's going to be a dashed line. Okay, so my solid line over here ain't so good. Come back to that. Okay, this one also going to have a slope of 1 going up and to the left, -1 rather. Okay, and there's my V, okay? Not perfect, but good enough for the moment. All right, so that's what I get when I graph just this y equals the absolute value of x minus 3. Now let's throw this part into it and talk about what happens when I make that y is greater than. That same rule that I told you about where y is greater than, you shade above the line, it still holds true. Good thing for you. Which means I'm going over here to where it crosses the y-axis, which which is here, and the numbers that are greater than are all on that side, which means actually everything inside of that V gets shaded in. All right, so any point inside of that V, when there's an infinite number of points in there, will be a solution to that inequality. And you could always go test it and plug it in. In fact, if I plug in, say I plug in 10, 0, let's say if I plug in 0, 0, do you get an answer that's true? I like using 0, 0 because it's easy to work with. So I got 0 is greater than the absolute value of 0 minus 3. The absolute value of 0 minus 3 is absolute value of negative 3, which is 3. Is 0 greater than 3? No, it's not. That's false. So therefore, that one's not a point in the solution set. However, everything on the other side of that V is. Okay? All right. We better do another one of those. Those are new to you guys, I think. 5. Yep, 5. Okay. Let's do y is greater than the absolute value of x plus 3 minus 2. All right. So, this one. Solid line or dashed line? Hopefully you can tell me right away that it's going to be dashed. Can you tell me the coordinates of the vertex of that absolute value? What would be the vertex? Start there. That's where I like to start when I'm graphing an absolute value. And if you have troubles with that, you should go back to the video earlier in this chapter all about absolute value graphing. So the vertex, this is going to be my x coordinate, except it's going to be the opposite sign than what you see there, which means it's going to be negative 3. This will be the y coordinate of the vertex, which is exactly the sign that it is, which is negative 2. And now I'm going to go over there and put that v down there, or the vertex of the v, negative 3, negative 2, which is 3, negative 2 here. Here's 2, negative 2 on my graph, 2, 2, negative 2. Okay, so there's going to be a v, it has a slope of 1 with a dashed line. Looking like that way, and that way. Okay, so I got the v. Now let's figure out which side to shade. Since its y is greater than, I'm going to be shading, yes, above the line. All right, so let me pick a different color here. Ooh, orange. Orange above the line. Shade everything up there. That is your solution area. Anything in there is going to be an answer. Okay. All right. So that's what I got on those. I got one more problem to show you. It's a word problem. Number 6. Right here. You go to an amusement park, one of my favorite things to do, and go on some rides. Tickets cost 25 cents and you have $15. The small rides, little wimpy ones, cost 3 tickets, and the big rides, large rides, cost 5 tickets. How many rides, small or large, can you ride? All right, so let's start here. This is actually going to be an inequality kind of problem. All right, so I'm going to go over here. I'm going to start with this. I'm going to label my variables. I'm going to have x and I'm going to have y, okay? If I make x the number of small rides I can go on, and I'll make y the number of large rides that I can go on. All right, so before we get too much farther, they're in tickets and then there's dollars. So I got $15. Let's talk about the cost for a minute. If I have $15, and let's see, it said, how many tickets can I get for $1? Did it say in here? Let's review that for a minute. Oh yeah, there it is. It says tickets cost 25 cents each, which means if I have $1, I could get 4 tickets, right? So if I have $15 and I multiply that times 4, that'll tell me how many altogether I can have, which is 60 tickets. All right, hopefully we're okay with that. Now over here on the left side, I'm going to talk about the number of tickets that we use, okay? All right, so on the right I got the cost, and on the left I got the tickets. Okay, so X, small rides. They said small rides are 3 tickets each. Large rides are 5 tickets each. Okay, so if I'm looking at just the number of small rides, that means if X is the number of small rides, each one costs 3 tickets. Large rides cost 5 tickets, and if I add those two things together, it'll tell me how many tickets altogether I used. And on the right, I've only got 60 tickets. That's the cost. So which one can't be greater? If I'm putting one of these inequality signs in here, which one's going to make better sense? Well, if I've only got 60 tickets, then that one better be less than. Otherwise, I use more tickets than I have. Okay. Now, can it be? Should we put a line under it? Yeah, absolutely. Because if you're like me, you're going to use every single ticket you got. Okay. So or equal to would be appropriate for this. Okay. All right. So now I'm going to solve this rather than manipulating this graph, the equation. I'm going to do it with x and y intercepts, okay? Which means I'm going to plug in x equals 0, and over here I'll plug in y equals 0. And we will find the y-intercept, and we will find the x-intercept. So that means I'm plugging in 3 times 0. Should put that in parentheses so it doesn't look like 30. 5y is less than or equal to 60. All right, so 3 times 0 is 0. 5y is less than or equal to 60. Divide by 5. And I get y is less than or equal to 12. All right, over here, plug in y equals 0. I got 3x plus 5 times 0 is less than or equal to 60. 5 times 0 is 0, so I get 3x is less than or equal to 60. Divide by 3. I get x is less than or equal to 20. All right, so let me make a quick graph over here. I think I'm going to do it up top here. And I'm only going to do a 1 quadrant graph. There's no need for negative numbers. There's no negative numbers involved in this. Okay, so I got x-intercept of 20 and a y-intercept of 12. So I'm going to spend a whole ton of time on this, making the whole thing. We said a y-intercept of 12 and an x-intercept of 20. If you want to make your graph more elaborate, feel free. This is x, this is y. And let's see, so if you're going to draw a line, the beautiful thing about that is once you've got the x-intercept and the y-intercept, you can just connect the 2 points and voila, I have a line. Now, you don't always use every single ticket at the fair, which means you're going to be using any point under here will be a solution. So, if I use 1 and 5 and I was to plug those numbers in there, that would work. That would also be a solution because you didn't use all your tickets. But that's how you do that, okay? And that's an important problem to be able to do. Probably one of those in your upcoming quiz or test, whichever comes next. All right, so I think that's all I got for this section. Close it out. Have a great night with some more music.